My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 631. In this lecture, we will look at some code for the dogs versus cats transfer learning problem. We will use VGG16 trained on ImageNet. This is actually a brilliant blog on the Keras blog itself. This blog is written by from Francis Cholet. He is one of the core contributors to the whole of the Keras. We look at some simple examples here. Let's assume I have 2000 training examples. So my dataset capital D equal to xi comma yi equal to 1 to 2000. I have 2000 images. I have 1000 images for each class. I have two classes. My yi belongs to cat or dog, isn't it? 2000 images are actually, I can say 2000 images are quite small to train a state of the art of convolutional neural network. So all of my data is organized like this. I have a folder called data, in which I have subfolder called train. I have images called dogs. All dogs images are there. I have folder called cats. Just see, you can see dogs folder, you can see cats folder. In dogs folder you can find all dog images. In cats folder you can find all cat images. I request all of you just go through this blog so that one can understand how nicely they organize this data. Just see, you have training data set as well as you have validation data set, isn't it? My training data, I have my training data folder. Similarly, I have validation folder in which we have dogs and cats images, and this data has been taken from this is taken from Kaggle. This is collected from Kaggle, even though Kaggle has 12,500 cat images. Just if you observe 12,500 cat images and 12,500 dog images, we will just use 1000 cat images, 1000 dog images. All these have been gotten from Flickr API. Flickr is basically online repository like Google Picasa for photos, and what they have done is they have taken thousands of images for each class. They have taken thousands of images for each class in training, and 400 additional samples for each class in the validation. So your size, I can say, so your size of the train is 2000, isn't it? What is the size of training images? Is 2000, and your size of test is 800 images, isn't it? Images of each class type, and you have just say this. That's what it says. We also have 400 additional samples from each class as a validation data to evaluate our model. Therefore, your size of D test is 400 images of each class type, isn't it? Therefore, there are two classes. Totally, there are 800 images. That is the size of D test. And if you want to look at some images, these are your just say these are your cats. Your cats, like just you can see the images of cats as well as you can see the cat images. You can see the dog images. Your cats in various lighting, various types of cats. Similarly, various breeds of dogs with various backgrounds. So let's look at this simple thing. First, let's do some simple data pre-processing. What is the data pre-processing? And well, first let's do some simple data pre-processing and augmentation. There is a very simple code snippet. To perform augmentation. Very simple code snippet to perform augmentation. Very simple code snippet to perform augmentation in Keras. You just say Keras dot pre-processing image. Just say Keras dot pre-processing dot image import image data import image data generator. Just you can check all these things, and you just say I wanted to just say image rotation underscore range equal 40 means what? I wanted to rotate about 40 degrees. I wanted to create images of width shift. You can see width underscore shift underscore range. What does it mean? I wanted to create create images of width shift by vertical shift. You can see the vertical shift by rescaling. You can see the rescaling the images by shear. You can shear the images, zoom transfer, flip sort of things. You can see some different types of transformations. All these are useful in creating new images, isn't it? I'm creating a data generator. I can say we are creating a data generator, which is basically data augmentation step. And once I create this, the way I will operate is this. This is, let me say, this is my data generator, isn't it? This is my and there is a beautiful documentation of Keras. Just see, there is a beautiful documentation of Keras. If you want to read more about image generator, we can simply Google search. Just simply Google search for image data generator Keras, or in Keras. You will get terrific documentation. I really like Keras for its documentation. Very well explained. Everything you want with some nice example. The amount of documentation they have is phenomenally good. So what I do now is, for each image, just see, for each image in my data set, isn't it? For each image in my data set, I will basically apply this image data generator image augmentation strategy that creates more images. Just to give an example, if this is my input image, let me assume this is my input image. These are all the other images that are created through data augmentation. This is been you can see in the flipped images, lot of things, similar images. Block cat is right side or left side, it doesn't matter. So they have done all of these data augmentations, and there is a nice code snippet here to explain you how this is done. This blog is very readable. Anybody can read it. So as a baseline model, what they will try to do, first step here is, let's build a convnet from the scratch. Very simple. Building convnet from the scratch is very simple. I can say very simple, with 40 lines of code. So let's see code snippet for base model in my next lecture. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.